The Sorites paradox, Sorites, sometimes known as the paradox of the heap, is a paradox that results from vague predicates. A typical formulation involves a heap of sand, from which grains are removed individually, with the assumption that removing a single grain does not cause a heap to become a non-heap. The paradox is to consider what happens when the process is repeated enough times, that only one grain remains. Is it still a heap? If not, when did it change from a heap to a non-heap? The word Sorites, Greek, Sorites, derives from the Greek word for heap, Greek, soros. The paradox is so named because of its original characterization, attributed to Eubulites. Another formulation is to start with a grain of sand, which is clearly not a heap, and then assume that adding a single grain of sand to something that is not a heap does not cause it to become a heap. Inductively, this process can be repeated as much as one wants without ever constructing a heap. A more natural formulation of this variant is to assume a set of colored chips exists such that two adjacent chips vary in color too little for human eyesight to be able to distinguish between them. Then, by induction on this premise, humans would not be able to distinguish between any colors. The removal of one drop from the ocean will not make it not an ocean. It is still an ocean, but since the volume of water in the ocean is finite, eventually, after enough removals, even a liter of water left is still an ocean. This paradox can be reconstructed for a variety of predicates, for example, with tall, rich, old, blue, bald, and so on. Bertrand Russell argued that all of natural language, even logical connectives, is vague. Moreover, representations of propositions are vague. The continuum fallacy, also known as the fallacy of the beard line, drawing fallacy, or decision point fallacy, is an informal fallacy related to the Sorites paradox. Both fallacies cause one to erroneously reject a vague claim simply because it is not as precise as one would like it to be. Vagueness alone does not necessarily imply invalidity. The fallacy is the argument that two states or conditions cannot be considered distinct or do not exist at all, because between them there exists a continuum of states. Strictly, the Sorites paradox refers to situations where there are many discrete states, classically between 1 and 1 million grains of sand, hence 1 million possible states, while the continuum fallacy refers to situations where there is or appears to be a continuum of states, such as temperature. Whether any continua exist in the physical world is the classic question of atomism, and while both Newtonian physics and quantum physics model the world as continuous, there are some proposals in quantum gravity, such as loop quantum gravity, that suggest that notions of continuous length do not apply at the Planck length, and thus what appear to be continua may simply be as yet undistinguishable discrete states. For the purpose of the continuum fallacy, one assumes that there is in fact a continuum, though this is generally a minor distinction. In general, any argument against the Sorites paradox can also be used against the continuum fallacy. One argument against the fallacy is based on the simple counterexample: there do exist bald people and people who are not bald. Another argument is that for each degree of change in states, the degree of the condition changes slightly, and these slight changes build up to shift the state from one category to another. For example, perhaps the addition of a grain of rice causes the total group of rice to be slightly more of a heap, and enough slight changes will certify the group's heap status. See fuzzy logic. One may object to the first premise by denying that 1 million grains of sand makes a heap. But 1 million is just an arbitrary large number, and the argument will apply with any such number. So the response must deny outright that there are such things as heaps. Peter Unger defends this solution. A common first response to the paradox is to term any set of grains that has more than a certain number of grains in it a heap. If one were to define the fixed boundary at 10,000 grains, then one would claim that for fewer than 10,000 it is not a heap, For 10,000 or more, then it is a heap. Collins argues that such solutions are unsatisfactory as there seems little significance to the difference between 9,999 grains and 10,000 grains. The boundary, wherever it may be set, remains arbitrary, and so its precision is misleading. It is objectionable on both philosophical and linguistic grounds. The former on account of its arbitrariness, and the latter on the ground that it is simply not how natural language is used. Timothy Williamson and Roy Sorensen claim that there are fixed boundaries, but that they are necessarily unknowable. Supervaluationism is a method for dealing with irreferential singular terms and vagueness. It allows one to retain the usual tautological laws, even when dealing with undefined truth values. Alternatively, fuzzy logic offers a continuous spectrum of logical states represented in the unit interval of real numbers. It is a many-valued logic with infinitely many truth values, and thus the sand transitions gradually from definitely heap to definitely not heap, with shades in the intermediate region. Fuzzy hedges are used to divide the continuum into regions corresponding to classes like definitely heap, mostly heap, partly heap, slightly heap, and not heap. Though the problem remains of where these borders occur, e.g. at what number of grains sand starts being definitely a heap. Another method introduced by Rothman is to use hysteresis, that is, knowledge of what the collection of sand started as. Equivalent amounts of sand may be termed heaps or not based on how they got there. If a large heap, indisputably described as a heap, is diminished slowly, it preserves its heap status to a point, even as the actual amount of sand is reduced to a smaller number of grains. For example, 500 grains is a pile and 1,000 grains is a heap. There will be an overlap for these states. So if one is reducing it from a heap to a pile, it is a heap going down until 750. At that point, one would stop calling it a heap and start calling it a pile. But if one replaces one grain, it would not instantly turn back into a heap. When going up, it would remain a pile until 900 grains. The numbers picked are arbitrary. The point is that the same amount can be either a heap or a pile depending on what it was before the change. A common use of hysteresis would be the thermostat for air conditioning. The AC is set at 77 deg and it then cools the air to just below 77 but does not activate again instantly when the air warms to 77.1. It waits until almost 78 to prevent instant change of state over and over again. One can establish the meaning of the word heap by appealing to consensus. Williamson, in his epistemic solution to the paradox, assumes that the meaning of vague terms must be determined by group usage. The consensus method typically claims that a collection of grains is as much a heap as the proportion of people in a group who believe it to be so. In other words, the probability that any collection is considered a heap is the expected value of the distribution of the group's opinion. A group may decide that, between the two extremes, individual members of the group may disagree with each other over whether any particular collection can be labeled a heap. The collection can then not be definitively claimed to be a heap or not a heap. This can be considered an appeal to descriptive linguistics rather than prescriptive linguistics, as it resolves the issue of definition based on how the population uses natural language. Indeed, if a precise prescriptive definition of heap is available, then the group consensus will always be unanimous, and the paradox does not occur. In the economics field of utility theory, the Sorites paradox arises when a person's preferences patterns are investigated. The concept of a heap can be defined as a geometric shape in space, such as a pyramid, composed of randomly arranged sand particles. The existence of a heap can be said to cease when there are no longer sufficient sand particles to maintain the defined geometric shape. This philosophical resolution, influenced by mathematical principles, was proposed by Alex Dragomir, a Romanian philosopher, in 2023. Thank you for watching. Don't forget to please like and subscribe. If you have a topic you would like to suggest, leave a comment.